Hello, and welcome back to the penultimate lesson of this unit. Exciting stuff. I don't know at the time I'm publishing this. I don't know if these lessons have technically been opened yet. But I'm on a video streak right now, so I'm just gonna keep rolling. Because I'm on like full vacation mode. It's hard to do, regular work. It's a struggle. I don't know if some of you noticed that. I'm just sitting at home doing much of nothing. So when I start to relax, like I'm on a Netflix binge streak. So when I start to work, I don't want to lose momentum. So I just crush these videos out in one stretch. So I don't know if you could tell. I could feel my voice getting hoarser and hoarser each video. Hopefully that doesn't show up. And I know my voice. I think my voice sounds incredibly funny and weird on recording. So hopefully you guys are okay with that. And I apologize if it annoys. Maybe I just drew attention to it and now you realize how annoying it is, and in which case I apologize even more. But either way, we're gonna continue with lesson 3.11. Here we go. Exciting. Linear quadratic systems. This is something that's kind of new to this grade 11, and again with the where it's not that difficult really, because we have to I really know what points of intersection means. So when it says solve each of the following by graphing or algebraically, what we're trying to find is the points of intersection between this line here and this parabola here. That's what we're trying to find, right? So how do we find points of intersection? What does point of intersection mean? Point of intersection is basically where, it's like if you have like two lines or whatever, like this point of intersection is where the x value and the y value for both the lines are the same. So for example, like if you take like x of 4, like this line has a y value of 5, whereas this line has a y value of 8. But if you take an x value of 1, this line, the first line has y value of 3, second line has y value of 3, and therefore that is a point of intersection. So if a point, so for example, this point 1, 3 satisfies or is shared between both those lines, that's a point of intersection. So if the y values, the x values for which the y values are the same, or if both the lines or both the equations have the same x value and the same y value, that is a point of intersection, right? So hopefully we're understanding graphically. Graphically we know what a point of intersection is, but hopefully now we're understanding algebraically what a point of intersection means. It means like, okay, let's find the one x value, or if there's 2 points of intersection, there's 2. So for example, a line can only have 1 point of intersection, right? But if we consider a parabola and then a line, we have 1 point of intersection here and 1 point of intersection here. So at the x value of negative 2.5, the y value for both the line and the parabola is like negative 2. At the x value of 3.5, the y value for both line and parabola is like 4.5. So they have to share the same x value and same y value, and then they have a point of intersection. So first, the easy way to solve for a point of intersection is graphically. Easy because like you just draw the graph, right? And this can be easy or hard depending on the graph. So here, let's graph these two functions. So I am going to do a bit of work to this guy before I graph it, because I don't like the way it is right now. But two numbers that multiply to negative 3 and, add to negative 2, or negative 3 and 1. So right away I can write x, x minus 3 times x plus 1. That's basically. So I have, my graph is going to look weird no matter what I do. So I have my roots. I have my axis of symmetry at x equals 1. So this is my axis of symmetry. Let's just find my vertex point. So y equals 1 minus 3 times 1 plus 1, which is negative 2 plus 2, which is negative 4. So 1 comma negative 4 is my vertex. And so my parabola looks something like this. And again, the problem is for a parabola, I don't know the exact points other than what I'm given. So it is gonna be kind of hard to determine exactly what they are graphically, but we'll do our best. So plotting the line x plus 1, hopefully, okay, do people plot different lines differently? You could technically do a table of values for both of these and then just plot the table of values. That is fine for graphing. The way I graph lines is I look at the y-intercept. So plot positive 1 is a y-intercept. My slope is rise over run is 1 over 1. So I rise 1 for every one I run. So I'm just going to, I'm going to run 1, rise 1. So here, run 1, rise 1. And that's going to give me kind of my slope, and then I just like draw my line. So my line is going to be, oh, whoops, that's not accurate. Like that, and my parabola is probably gonna, it's hard to tell where it's gonna intersect graphically. I can say one point of intersection is definitely negative 1 comma 0 is a point of intersection. The other point of intersection each, that's hard to say really. Based on my hand-drawn graph, I'm gonna suggest it's about 4.5 here. The easiest way to kind of check it is just plug in my value. Again, I would probably put in both 4 and 5 into a table of values. So I know what that is. So this is going to be 4 and 5. So if I put into this, if I put y equals 4, I have, if I put table of values, x, y, 4, I have 4 squared is 16 minus 8 minus 3. 16 minus 11 is 5. So actually that works. So at 4, the y value is 5. So my parabola actually passes through this point, which is again hard for a rough sketch, but if you had a table of values, you would, 4 comma 5 is another point of intersection. Again, if you're asked to draw it graphically, and that's for actually marks like it is, I'd recommend doing a table of values, especially when you get close. So rough sketch it to kind of get an idea of what values you actually need to put in your table, and then put those values in. So I saw that my line, it probably intersected somewhere between 4 and 5, so I started plugging in 4 and 5. If 4 hadn't worked, I would have put in 5 and I would have solved it for the parabola, and so on and so forth. That's again, I'm more of an algebra person. So the idea is, okay, how are we going to solve this algebraically? So we want to find the x values. So for what same x value do these things have the same y value? So what we're going to do is we're going to set the y values equal to each other. So we're going to say x plus 1 equals x squared minus 2x minus 3, because at our point of intersection, my y values are the same, so this equals this. And now I just have to find, okay, what are these x values that are giving me the same y values, right? So I'm just going to rearrange this, bring this both of these to the side. X squared minus 3x minus 4 equals 0. Two numbers that multiply to negative 4 add to negative 3 are x equals x minus 4 and x plus 1 equals 0. So x equals 4 and x equals 1. And now I can put these values into either one of my equations. So I can put it into this one, or I can put it in this one, and you will get the same answer. So if I want to find my point, right? So I do have to find my y value. I can either say 4 plus 1 is 5, Or if you want to put this 4 into your parabola, you should see that you get the same answer. So 4 squared minus 2 times 4 minus 3 is 16, minus 8 minus 3 is also 5. Whoops, this is negative 1. So y equals 0. Or I could do negative 1 squared minus 2 times negative 1 minus 3, which is 1 plus 2 minus 3, which is 0. So you'll see here that I'm getting the same y value when I put it into both these expressions. So my points of intersection are 4, 5 and negative 1, 0. Those are my points of intersection. So again, not that hard. Hopefully algebraically, you just set them equal to each other and solve. Graphically, it is a bit more messy, I guess, but not impossible. So we'll try and graph this guy over here. I'm going to use the method of partial factoring. Whoops, what am I saying? So the symmetrical points are 0, 5 and 4, 5. And 4, 5. My equation of axis is 2, so I'm going to put that in my graph. So 2 times 2 squared minus 8 times 2 plus 5. Hopefully we haven't forgotten all of this. 8 minus 16 plus 5 is negative 3. Is it? Yeah, negative 3. So at 2 I have a value of negative 3. This is going to be annoying to graph. That's my graph. And again, I start with my y-intercept at negative 1. And then for every 4 runs, I rise 3. So I'm going to run 4, 1, 2, 3, 4. I'm going to rise 3. 1, 2, 3. Run 4, 1, 2, 3, 4. And rise 3. Sorry. 1, 2, 3, 4. Rise 3, 1, 2, 3. So that's over here. So already, I don't even need that extra point because I already have my 2 points of intersection right here and right here. Those don't look like nice points of intersection to me. Not at all. Unless, like, again, my parabola is super wonky. So again, I see here that it's somewhere between 1 and 2. I'm going to try x equals 1, put that in a table of values. So for my parabola, and this is for my line. So x equals 1 means for my parabola I have 2 minus 8 plus 5. So 2 minus 8 is negative 5. Is it? Yeah, these aren't going to be pretty solutions. Hold on a second. Let me see what the answer key is. So that's pretty cool. I just there is a way to graph parabolas better. Once you find the vertex, you know that you can, like, you know, go 1 and then up 1. So like at vertex is at 2. So like, oh, but then it has an a value of 2. Oh, this is annoying. I don't know. This is, I guess, like, okay, like if you look at y equals x squared and you have your vertex point, you know, if you go 1 to the left and 1 to the right, you're going 1 up, and then 2 means there's 4 up, and 3 means there's 9 up, and things like that. So we're kind of using the same idea, except now we're multiplying all the y are going to be multiplied by a factor of 2 because my a value is 2. So at 3, I go up 2. So technically my points, let me erase my parabola, try and graph it better. My line is good, I think. I have a good line. My parabola needs some work. No, my line. Oh, whatever. Okay, so my line was here. My vertex was here, but I'm going to go 3 and 1. I go up by 2. So here's my points. And at 4, I did have, what were my points from before? 0, 5. And 5. Is that 4, 5? Oh, those were my points. So I can get up to, oh, I still can't draw. Again, though, oh my god, that's so curvy. No. Okay, guys, I really give up. Well, okay, if there's, you know what, I'm gonna do this algebraically. If there's exact value, if there's answers, I'm just gonna draw my graph to fit that. I can't, like, again, the way I'm drawing this, like, it doesn't really lend itself to proper straight, you know, nice looking lines, and I really have an unsteady hand. I can't draw straight lines for the life of me. So we're gonna ignore all that, and sorry about that. We're just gonna proceed with the same idea. At point of intersection, our x values are equal, our y values are also equal. So since our y values are equal, I'm gonna set them equal to each other. So this equals this because y equals y for both those two expressions, right? So I have this, oops, forgot the x. I have this kind of guy here. Okay, there's different ways you can do this. I don't like this 4, so I'm gonna kind of take a common denominator here. I'm gonna remove as many fractions as I can before I work. 3x minus 4 over 4, right? And then I'm going to multiply the 4 up into this expression, so I get 8x squared minus 32x plus 5 equals 3x minus 4. In retrospect, I probably shouldn't have done that because that just wasted my time, because I have to solve for x, so I have to use completing the square anyway, so that's going to be some messy fraction. Sigh. Oh well. So I'm going to start completing the square using this information. So this is where I'm going to start. And again, I'm going to jump through a couple steps here. X squared minus 35 over 8x equals. This does not look like a pretty completing the square. I'm already scared of it. Sigh. Okay, then we're going to take negative 35 over 8. We're going to divide that by 2, which gives us negative 35 over 16. And we're going to take the square of that. Really? Really? Yeah. What? Oh, man. Again, you know what? No, we're not going to do that because I have a life to live. We're not going to do completing the square. We have technically known that to find the solution, we can use our quadratic formula. I'm going to do it that way because, you know, you only live once. And yeah. So x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. Equals, here we have negative of negative 35, positive 35, plus or minus b squared is 35, or negative 35 squared, minus 4 times 8 times 9, divided by 16, 2a. Let's take a look at what this guy is. 35 squared minus 4 times 8 times 9, 937. And of course, that's not square rootable. So basically, this is my points of intersection. 35 plus. So this is my x values for my point of intersection. 35 plus root 937 over 16, and 35 minus root 937 over 16. Now technically I do have to put that into my expression and come up with my y values, but luckily, you know, I can put it in my line expression, so 3 over 4 x minus 1. So all I have to do, well, air quotes all I have to do. Y equals 3 over 4 times 35 plus root 937 over 16 plus 1. And for this x, it's the same thing, except with the minus. Let's finish solving that. I guess 4 times 16 is 64. I take like a common factor times 64 times 64. To multiply this into this. So 3 times 35 is 105, and I have to add 64 to that is 169 plus 3 root 937 divided by 64. And this is like the same thing, except 169 minus 3 root 937. There. So my points of intersection are, x, comma, y, and x, comma, y. I'm not writing that out again, but there you go. Obviously, those are like weird looking. I don't even want to know what kind of points they are, but yep, I'm going to leave that there because I'm interested in calculating that. I mean, we can kind of see if, okay. What is 35 minus root 937 divided by 16 is approximately 0.27. So I'm saying it's like that. So, and my y value should be somewhere on -1. So let's look at that y value. 169 minus 3 root 937 divided by 64 is 1.2. Why is it 1.2? Did I make a mistake somewhere? Oh, I don't want to have made a mistake somewhere. No. Why? Why is my life so hard? No. This does not match up. Oh, is it because... No, the graphs are right. Did I do something wrong? Here? Yeah, I had to, because I put it in that equation. What did I do wrong? Is it 3 over 4x minus 1? Yada yada. It's making my life so hard. 105 minus 64 is 41. Okay. 41. Okay, I'm sorry for wasting your time. You should have, hopefully you skipped past all of this. I was just trying to check whether it was kind of the same point that I was seeing here. And if you do like 41 minus 3 root 937 divided by 64, you should get negative 0.79. So this appears to be a point of intersection, which kind of makes sense because if you draw your parabola nicely, you will get that point of intersection. Whatever. Moving on. Okay. After all this time. Okay. Sorry about that. We're getting to the easy stuff. We're getting the good stuff. Here, because we're not actually finding the points of intersection, we're finding the number of points of intersection. And again, the key here is doing our discriminant. So again, for f of x and g of x at point of intersection, we see that f of x equals g of x because the y values are the same, right, as we talked about. So 3x squared plus 12x plus 14 equals 2x minus 8. Move everything to one side. Plus 10x plus 22 equals 0. So again, we have to find the number of points of intersection. So obviously, if we have a parabola and a line, our parabola could have 2 points of intersection. It could have like 1 point of intersection like this, or like, for example, like this. And for those of you who've taken physics, this line is called a tangent. If the parabola and the line have 1 point of intersection, the line is a tangent at that point to the parabola. Or, of course, you'd have a parabola and your line could completely miss your parabola, never intersecting this parabola ever, so 0 points of intersection. As there's 3 cases, there's 3 solutions. You can have either 2 solutions, you can have 1 solution, or you can have 0 solutions. And if that's familiar, hopefully it should be, that's because we've done this thing before. So basically, if we do our discriminant here, which is b squared minus 4ac, which is 100 minus 4 times 3 times 22, which is in fact, I don't even know what this is, but I can tell you that it's lesser than 0. 88 times 3 is 240 plus 24 is 264, so negative 164, which is lesser than 0. So since d is lesser than 0, there's no solutions. So what does that mean exactly? There's no value of x for which f of x equals to g of x. That this x does not exist. There's no real solutions for x, is what that means. So this is the case that there's no solutions because there's no value of x for which our y values are the same. And so that's how we do that, very similar to our thing there. Determine the equation of a line that has a slope of -6, intersects that function once. Okay, so our equation of line is y equals -6x plus b. We got to find b. Intersects this function once. So instead of y, I'm going to say g of x is the equation of the line. Again, at point of intersection, blah, 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 f of x equals g of x. So we can say that 3x squared minus 6x minus 7 equals -6x plus b. We don't know what b is, but we will rearrange this to one side. We'll bring 3x squared minus 6x plus 6x is 0, -7 minus b equals 0. So our a here equals 3, our b equals 0. Oh, that's confusing. There's 2 b's. That's annoying. Let's call this something else. We're gonna write instead of b, we're gonna say plus. What do you want to call this? Like m is a slope. Like, you know, like equal to mx plus b, but there's a b here as well, and there's, okay. We're going to say y equals mx plus, we're going to create a new form. Instead of b, we're going to write p, just for fun. So as to not get confused, and because I can easily change this to a p. Okay, our b coefficient of the x term equals 0 because there's no x term, and c equals -7 minus p. So now my b squared minus 4ac becomes 0 minus 4 times 3 times -7 minus p. And we want our discriminant to be equal to 0 since line intersects parabola only once. Our discriminant has to be equal to 0. Again, that's what... because we need to have only one solution to our linear quadratic system. And therefore, what was I saying? Yeah, so 0 minus whatever this is, 12 times -7 minus p equals 0. So -12 times 7 is 84. Well, I mean, p equals -7. Kind of get that from here as well. I'm kind of wasting time. But yeah, however you get to it, p equals -7 should be the answer that you get. So your equation of the line here should be -6x minus 7. That is the equation of a line for which this is the line that intersects this parabola exactly one time. So we're going to quickly look at some of the homework here. 4, 10, 12, 14. Okay, that's nice and easy. What question was it? What page? 198. 4, 10, 12, 14. I'm going to forget. Okay, determine point of intersection. Okay, algebraically you know how to do this. Again, you just said g of x equals f of x, rearrange everything to one side, solve for your x. You can solve using completing the square method or a quadratic formula in this case, but you should know how to use completing the square by now. That's the hope. So that's that. 10, 12, 14. Huh. So these are some interesting looking questions. We might have to spend a bit of time on this. So what is happening here? So he's jumping from the CN tower, so that's a parabola, and after at some point he releases his parachute, at which point he like kind of glides down in a straight line. So if you like kind of extend this parabola going this way and extend this line, this point where he releases his parachute is the point of intersection, right? So essentially, I mean, what you have to do is you just take like this, you set it equal to this, you find the height and time. So you find that point of intersection between the line, or where that point of intersection is essentially where he released his parachute. You might get 2 points of intersection if you like extend this line, but you're going to ignore this one because it should be, you'll get a t value that's lesser than 0, and obviously you reject that and to favor the other t value. And that's how you do that question. So I'm not going to do it because we've done several questions like this. Again, the idea is simply you set the y values equal to each other because you're looking for a point of intersection. Let's look at this. This is very similar to the last question that we did. You're just going to say f of x equals g of x. You're going to rearrange everything to one side. Plus 4x minus mx minus 2 plus 5. We're going to factor out an x from these two terms. 4 minus m. So this is our a. This 4 minus m is our b. This is our c. So you can do b squared minus 4ac. And again, what value would make it a tangent? I mentioned this in the lesson. A tangent to the parabola means there's only one point of intersection. So you do b squared minus 4ac equals to 0, and you kind of find your m. That's straightforward. Okay, this is just a punter kicks a football, blah, blah, blah. This is the height. This is the football, the height of the blocker's hands. So is there a point of intersection or not? So can the blocker knock down the punt? So if there is a point of intersection, then yes. If there's no point of intersection, then no. If so, at what point? So you have to solve this anyway, so you might as well not use you might as well use the quadratic formula to solve that. So that's that. What else do we have to do? Oh, just 14. Determine the coordinates of any points of intersection of these two funny looking functions. Again, it's not that complicated. Again, at the point of they're just not given in like a regular form, but at a point of intersection, the x and the y will be the same, right? We know that. So we're just going to rearrange for 3y here equals negative x squared plus 2x minus 6. And here 3y equals negative 6 minus 2x. We're just gonna, substitute, set if y equals, so hopefully we can see that if y equals y, 3y equals 3y. So you can divide by 3 and, make it a hassle, but essentially what you're doing is okay, if you want to be systematic about it, divide both sides by 3 here, and you get negative x squared plus 2x minus 6 over 3 equals negative 6 minus 2x over 3, whoops, 3, and then you'd multiply both sides by 3, so these 3 would cancel, and you just get this equals this. Rearrange everything to one side, solve for x, quadratic formula, blah, 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 easy stuff. So that's that lesson. So hopefully you were okay. Again, maybe I should have spent more time. So linear quadratic systems are basically looking at the different points of intersection between a line and a parabola. The idea is the main example here is put a star beside this one, because to find the number of points of intersection, the basic idea is you set them equal to each other. If you're asked to find the point of intersection, you have to use the entire quadratic formula and solve it. If you're asked to find number of points of intersection, it's a similar idea to finding the solution. So you just set them equal to each other and find the, your number of x values. So using your discriminant, and that's that. So hopefully we understood what was going on there. It was easy. And exciting news, we're almost at the end of this unit. So I will talk to you guys next lesson. Until then, peace out.